I hope this video and this video series will give you a good introduction to NLP, or Natural Language Processing. In this particular first video, I'm going to talk about what is NLP, the evolution of word embeddings to the general idea of how things work today, sharing your NLP models and getting other people's models from the community, and approaching a new NLP problem. As I said earlier, NLP stands for Natural Language Processing. It's a particular type of machine learning or AI that focuses on language or trying to understand text. Examples of an NLP problem include trying to understand the feeling in a Facebook post or whether a tweet is left-wing or right-wing politically. You could answer a question based on a Wikipedia article and someone typing in a question like Siri. It could be translating between different languages or between more advanced technical English to more simple English. It can also be used to summarize complex documents like legal and medical resources, which would be difficult for a human to read through every time they want to find what they're looking for. Machine learning is a much broader scale. Things that kind of overlap with NLP and text a little bit, but I don't really think of as NLP problems include um, image recognition, knowing what objects are in an image, and multimodal tasks such as these memes from the Facebook meme challenge. There's a little bit of NLP there, but it also overlaps with other tasks, which I'm not going to talk about in this lecture. Kind of a classic example of an NLP problem is knowing, is this a positive or negative post? And if you just read these Google Maps reviews here, I've hidden the star rating, but it's pretty easy to tell that fun, friendly atmosphere is a positive review, and waitress was absolutely terrible is a negative review. How do we know that just from looking at 3 or 4 words in a review? So if you were trying to get a computer to do this on its own and you had no access to any other resources, you'd probably come up with a word list. This is basically how NLP got started in the beginning. You come up with a list of good words and a list of bad words to have in your Google Maps review, and then kind of figure out what kind of words show up there. Over time, natural language processing found that it needs to get more advanced and more than just word lists. For example, in that first review, they said karaoke is great. If you didn't anticipate karaoke and you had music on your word list, you wouldn't have caught it. So either our word list has to be really big, or it needs to be able to identify synonyms. Scores for each word. For example, if someone writes best in all caps, that's probably better than just saying okay. Structure of the sentence. This is when things start to get more complicated, because if someone says the restaurant could be better or couldn't be better, they mean the opposite things, and there's not one word in there that tells you is it positive or negative. This means that our ideal system should be able to understand the structure of the sentence and look across multiple words. A big advancement in 2012 was Word2Vec, which starts turning words into vector problems. So just like an image can be broken down into pixels, and that makes it easier for a computer to process it, breaking text down into word embeddings or word vectors makes it possible for a machine learning problem to process it without really thinking so much about it as a text problem. Where do these vectors come from? Well, the Word2Vec idea was you could train it on a very large amount of text before you start your problem. So go to Wikipedia, go to movie subtitles, and see how do words relate to each other, like how often do they appear next to each other. And so in the center top of this map here, you'll see that government, minister, party, president all appear kind of in a cluster. So those words are related to each other. In the actual model of that, and actually word vectors that are used today, there are hundreds of dimensions. It's hard to kind of picture this, especially since we have a two-dimensional slide, but there hundreds of dimensions allow you to easily say, okay, these words are synonyms, these words are opposites. This is like king and queen are related to men and women. There's all sorts of different things you can draw just from word associations and plotting them out in vector space. So Word2Vec really brought this to people's attention of being a good way to solve this. And then since then, there have been several different twists on this. BERT, GPT-2, other kind of famous NLP models have, at the beginning stage, just a system that maps words into vectors. And another thing that's being shown here on this plot is you can do that with other languages other than English. So if you plot the German word vectors, because English and German are very closely related and have similar vocabulary, you'll be able to move the plot around so that the English and German word vectors are very closely connected to each other, or just at a known offset from each other. This makes it possible to translate from one between English and German. I know you can't just replace the words one by one uh, with their translated equivalent to translate a sentence, but this was a huge advancement for cross-lingual understanding in machine learning. NLP isn't perfect. There's a lot of reasons that we say it doesn't really fully understand language, and then if we get outside of English, Mandarin Chinese, and a few other commonly researched languages, then you might have fewer than 10 gigabytes of text data to work with on the this comes from like the Oscar corpus that has kind of crawled the internet and found as many resources as it can in each language. You might say, oh, 2 gigabytes of text, that isn't very much for Burmese. And it isn't from an NLP perspective, but it is huge from like a human perspective. That's a lot of text. That's many thousands of pages of information. So it's kind of disappointing that a machine can read through all of that text and still not really get good results on understanding Burmese. So there's a lot we could do for NLP to better understand language when it only has a small number of gigabytes to work with. Another problem is updating. Once we've built that model in 2012 or 2016 or 2018, developers often don't go back and update it. If I gave you this sentence, temperature checks are required for all visitors, and everyone over the age of 2 must wear a blank, then if you're living in the year 2020 or 2021, it's quite obvious that you would say must wear a mask. But if you're dealing with a model that was happening from before, I've actually run this experiment. It says it must wear a scarf, must wear a uniform. You can't think of the item there because it hasn't been updated, and there isn't a really strong way of patching in a little bit of text. So that's something I'm interested in researching myself. And again, NLP does not fully understand what it reads. So if you were asked a new question, not is this a positive or a negative review, but recently I've been wondering, does the review report that customers and employees are wearing masks? So here we see some negative reviews where people were unhappy with a pro mask policy, and some positive reviews where people were happy with a pro mask policy. And so the star rating is no longer important. What I want to know is, can NLP understand this text and plot it into a pro mask review? And that's something that I can't just do with an existing model. I would have to go back. Well, I would have to collect hundreds or thousands of these reviews to get a really high scoring model or label that knows the difference between these categories. So if you're doing a brand new NLP model, you would collect a huge data set of language. You would pre-train those word embeddings from the very large corpus of text. And luckily, these pre-trained models, there's many of them out on the web using on websites such as huggingface.co and adapterhub.ml and TF Hub, TensorFlow Hub. They all have these word embedding models ready to go. So if you have a language that is well covered by those, you can start with step 3. If you're in a language where that data set or that model hasn't really been very well developed yet, you're going to have to start from step 1. But if you're in English, if you're just doing something with uh, restaurant reviews or something like that, then you might start with step 3, collecting your data set for your particular problem. Then you do a particular kind of training called fine tuning. They'll take the existing model and tweak the weights, strengthen the meaning of some words and that, and add an additional layer at the end that determines which category it falls into. There's classification, there's regression. I won't get into that today, but just this concept of there's a huge resource of models, and then you can find one and fine tune it for your particular labeled supervised problem. You might ask, why are these not hosted on GitHub? Um, the main reason for that is that some of these models are huge, like multiple gigabytes. So GitHub doesn't really support it. Some people have shared them on Google Drive, um, but there's a variety of different solutions to this, and it just helps to go someplace where other people have shared theirs. And then once you've fine-tuned your problem, you can share it as well and get people to test it. One way that you can also share your work and show examples of what you're doing, especially if you're talking to someone who might not even know or understand the language that you're working with, is to make a notebook where you can combine text and code in this more transparent format. And after each block of code, you can see the output of that and understand what's the current state. Um, some benefits of this is you can share it. You can handle installing Python libraries that if they don't work very well on your system, you could just have it installed in the cloud. It has very fast download if you run your notebook on something like Google Colab or Nextjournal, because it'll just download from cloud to cloud and not down to your individual computer. I also really enjoyed using Google Colab in particular because I can use a GPU or a TPU hardware which can do faster training. This is just the first video. I'm planning to do one on simple transformers, which I use for a lot of my projects. I'm also planning to do a video about just learning styles for machine learning. So just the difference between doing reading from the book, watching lectures on YouTube, and messing around with different libraries and notebooks, which is kind of my preferred style. But I want to give intros to all of those, and I'll try to continue this series.